Hello everyone. I'm Ranjith. You can call me RK. I'm CTO at Searce. I've been a cloud practitioner for close to a decade now. Today, I'd like to take you through this session on how to build enterprise data lake on AWS and GCP. So let's get started. I'm from Searce. We're a niche cloud AML partner for digital natives. We've been around for about 14 years now. Been doing cloud for close to a decade. We are one of the premier partners with Google. We have won APAC Partner of the Year award 4 times in a row. We're also an advanced consulting partner with AWS as well. We have presence in across 5 countries, 14 different locations, 650 plus people and counting. We have served more than 3,000 customers, worked with all types of customers from a 2-person startup to huge conglomerates. With that said, let's get started with the presentation. So depending on where you are coming from, what kind of organization, I'm sure you're familiar with some or at least most of these terms that you're seeing on this deck, data lakes and data marts, data warehouses, and also, operational data source, data stores, etc. Data is new oil is by now a cliche, but then data is important, cannot be overstated. There are a typical organization generates a wide variety of data, on-prem, cloud, edge. There are videos and emails and structured and unstructured data, point of sale systems, and your websites, cookies, your ad related and marketing tracking related data. If you're working with any external vendors or service providers, and consuming their services, there is data generated there as well. There are aggregators, multiple reports, etc., that you need to build, right? So if you look at this, things are messier than they are before, purely because we are dealing with different types of data from different places, and its volume has increased. So some of the challenges that the enterprises face today are, they probably started with an enterprise data warehouse and some outdated KPIs, which are, since then there are more data sources which are added, but all of that insights are not, translating into these KPI dashboards. Lack of data-driven culture, ability to use different tools and governance mechanisms, etc. And another challenge is lack of skills itself. There are newer tools now, newer processing techniques now, and better kind of insights that can be driven. But the rate at which these tools change and increase, the skills are also not increasing, in an enterprise landscape in general. And we already talked about proliferation of different sources from on-prem, cloud, and external channels, and the velocity with which we receive this data, right? And another challenge is that the process of extracting insights from this data, sharing them, and performing analytics, etc., are all manual. And obviously, all of these have a lot of business impact, right? So there might be insights which are hiding in the plain sight, which can improve your business's bottom line, which are currently not being derived because of all of these challenges. So from that background, it is actually time for the data strategy refresh with cloud. And in your to-be state, in a perfect state, once these issues are addressed, the end result will probably look something like this, right? So you have multiple data sources, OLTP databases, and enterprise applications and third-party services sending data. You ETL, some of that goes to data warehouse, and then other type of data, like web logs and unstructured videos, etc. Basically, all types of this data will go to the data lake too, and with the combination of because the data warehouse is kind of complementary for the data lake, using all of these, you will be able to come up with purpose-built data marts, which will enable different kinds of analytical use cases, right? So KPI dashboards and financial reporting, and just enable raw data for export for external users, so on and so forth. So far, we discussed, how there are different types of data and why things are messier, etc. Right? And I'd like to take you towards, make a case for building a data lake to address some of these concerns that we spoke about. So let's start with a typical enterprise organization, right? So we already spoke about different types of data sources. You can have relational data sources like Oracle, SQL Server, MySQL, Postgres, etc. There's data coming in from sensors as well, videos and audio, social media, and then the traditional systems that an enterprise has, like ERP and CRM. And if you have deployed your web servers and application servers in auto-scaling mode, they generate a ton of logs and other logging as well. You ideally would like to be able to ingest all of those and derive insights out of it. We'll talk about what kind of people are involved in a typical organization, right? So we have business analysts who are familiar with SQL based tools, or Excel, or drag and drop interfaces, using which they can actually come up with their insights, or build reports and charts, etc. We also have a data engineer who typically wrangles with this data, that comes from these different sources, both real time and batch, and a data scientist, who's usually consuming this data, which is wrangled by the data engineer, which is made available, and performing interactive analysis and coming up with machine learning models, so on and so forth. And there are application developers as well, typically your polyglot programmers, who consume all of this data and then build API interfaces, etc., for downstream consumption. Maybe you'd like to enable this data access to your customers in a secure way, etc. So we talked about different types of data sources and different kinds of people, that are involved in an organization, and their tool chain as well, right? So a business analyst, like we already spoke about, uses the drag and drop kind of tools or SQL based querying, and they're likely to build reporting dashboards, KPIs, etc. And a data engineer, custom Python scripts or some Python framework, uses orchestration tools like Airflow, uses Beam to wrangle with this data, etc. And the data scientist, a machine learning library of their choice, like TensorFlow or Keras, probably spend most of their time on Jupyter notebooks, right? And then the application developer spending time, consuming this data, consuming the models, and building API interfaces or applications on top of this for analysis. Like we already talked about, all of this data, how does this get accessed, right? So in the form of dashboards, which may be for internal users, some of this embedded in the website for external users, and then API interfaces, etc. What we wanted to establish with this is that a typical organization has been generating more data than ever, because even refrigerators also generate have IP addresses these days and generate data. And the variety of the data also increased. There are videos and there are audios, etc. And then there are different types of people, and they use different tools. And once you expose this to the customers, your end users or your customers, the access patterns are different. Some internal, some external, and the ways the end users interact with this data is different. With that, we'd like to make a case for building a data lake, because currently the data is in silos, right? So, for example, if you look at some of the tables or most of your applications which are supported by relational databases in the backend, the custodians of that data which is currently in the relational database, who is it generally? It is a DBA, right? There is a different way to access it. If you'd like to get data from here, either you write batch jobs, etc., to extract data. You have to worry about not disrupting production, availability of read replicas, so on and so forth. So, and then it's just about the relational database itself. There are also other data sources, non-relational, etc., right? So there are different collections of data which are being independently managed by different sets of people in a typical organization today. And that poses the challenge of data discoverability, right? So when there are multiple custodians and data is in different silos, it is possible that some part of the organization does not know the existence of a data set which might be useful in enhancing the bottom line of the company. So it's a problem of data discovery, right? And that comes because there is no single source of truth. It's not just in one place, and because of that, even if you figure out that there is some data which is available in a relational database that you can use, then you will spend more time on ETL, right? If it is Oracle, then you will be looking at OBI. If it is SQL Server, then you are looking at SSIS, and come up with jobs which are specific to it, so on and so forth, right? The point is, you spend more time transforming, extracting data and loading them, and less time on analytics, because it's not already made available to you in a form that you can consume, right? So that's another challenge. Also, the inability to apply multiple processing techniques on same data to extract insights, right? So, for example, this relational database currently has a bunch of tables, multiple millions of rows, and using this, it's a no-brainer to come up with a fact and dimensional data model, build operational dashboards, so on and so forth. But maybe that same data can also be used for coming up with a prediction model or a forecasting use case, right? And that is difficult in the current setting that we are talking about, because the data is kind of currently stuck in different places, right? So it's not easy for you to apply multiple processing techniques. It is possible, but it would take effort, right? So, and difficult to perform predictive analytics and ML, and use some of the advanced analytics techniques, which is why we already data lake means different things to different people. I have seen customers who have built who treat their enterprise data warehouse as the data lake. For some, the operational data store kind of behaves like a data lake. Keeping all this in mind, our journey in this session so far, I kind of wanted to define what a data lake is, right? So, a central repository of data, ingested in its raw format. So, a capability to capture every kind of data or every aspect of data that your business generates, no matter what type of data it is, relational, non-relational, and all other different types of data sets that we spoke about. So ability to capture all of this and store them in a central place in raw format, and ability to catalog all of this data and provide, if you recollect, one of the things was the discoverability. So when we have all of this data in one place, properly cataloged, and a search interface is available for the metadata, by which you can find out what data sets are available, and then how they can be used, and make this data available for diverse groups of users, right? Obviously, with the right access controls associated with these data sets. So to sum up, ingest all of the data in its raw form in a central place in a data lake, and identify what can be, what kind of insights can be gathered, can be derived out of this data, figure out the right tool, like build for KPI dashboards or other ad hoc analytics, etc. Build an enterprise data warehouse and purpose build data marts, which cater to specific use cases, and also real-time analytics and machine learning, etc. So that is essentially a data lake. Now, we have been building enterprise data lakes for quite some time now. I've seen customers at one point in time building their enterprise data lakes on Hadoop-based systems. And then they'd use a processing tool of their choice, like Hive, Presto, or Apache Hawk, for building an enterprise data warehouse on top of it. But all of that would take a lot of effort, right? So building these on-prem and maintaining these and patching these systems, so on and so forth. Since the advent of public cloud, and especially because the service, the object store, which is available in both AWS and GCP. In AWS case, it's S3. And in GCP's case, it's Google Cloud Storage. Both are similar, for all practical purposes, are infinitely scalable object stores. Both have rich metadata management capabilities, and also different tiers of storage as well, right? So if you're ingesting huge amounts of data, so we talked about how data lakes are supposed to enable you to ingest any kind of data in its raw format, right? So when you start piling up data like that, you'll quickly amass a lot of data. So both these platforms have ability to write object lifecycle policies to retire data after a certain time, to infrequently accessed, and other tiers of storage which are less costlier, and it depends on your availability and durability requirements. So in this slide, we'll talk about how to build an enterprise data lake on Google Cloud. We have helped some of the large enterprises to build enterprise data warehouses on Google Cloud. So at the center of this, as you can see, is the object store, which is the Google Cloud Storage here, also known as GCS. And also, you'll notice that in the diagram, there are different sections, right, for data ingestion, cataloging and searching, access and user interface, processing and analytics, and protect and secure. These are essentially the characteristics of a data lake, right? So if you recollect from the previous slide, we talked about ability to ingest any kind of data and cataloging and make it available for our users with right security, and also ability to choose the right processing tool for your analytics use case. So we'll start with the data ingestion part here. You see the transfer appliance and GS util. If you have large amounts of data, multiple petabytes, it would be difficult for you to ingest this via internet. So there are options for you to speed up this ingestion. You could connect your on-prem data center with Google Cloud's VPC, for example, using interconnect, which is kind of like point-to-point connectivity. You could also, gain some kind of transfer acceleration using UDP transfer tools. But if you really have massive amounts of data and you'd like to ingest it, then transfer appliance, you could request for an appliance which will be shipped, which is a physical device. We can load the data, and all of this can be ingested to Google Cloud, which will be made available to us in the region of our choice. And also, if you would like to ingest real-time and batch data, then there is Cloud Dataflow and PubSub. Often you will see them together. Dataflow is managed Apache Beam. PubSub is kind of managed Apache Kafka, managed Kafka. So using Cloud Dataflow, you will be able to address both real-time data and also the batch data. On the in-flight real-time data, you will also be able to perform sliding window analytics, etc. That is more relevant on the processing side of it, which is why you see Dataflow on the processing and analytics side too. And also there is Cloud Composer and Data Fusion. Data Fusion is basically CDAP, which allows you to author the ETL jobs using a drag and drop mechanism. Supports all well-known data sources. And Cloud Composer, if you would like to author Airflow tags, achieve complex workflows in your data extraction, and then changing data between multiple systems, etc. Then Cloud Composer is actually managed Airflow. And if you have data that needs to be ingested using custom logic, there are options to host that logic on Google Cloud. Cloud Functions, which is serverless and just function as a service. You could also deploy your logic on GKE, which is managed Kubernetes cluster on on Google. And there is App Engine and Compute Engine as well. VMs and App Engine is PaaS. And coming to the catalog and search characteristic of the data lake, the services that we can use, there is already data catalog, which is a service which helps with data discoverability. Your data sets that are on BigQuery, etc., and PubSub, you will be able to search them, and the catalog service is helpful that way. Or we talked about the metadata management. So basically, everything that you ingest, or basically everything that you store on cloud storage or an object store is an object, and using the metadata management features available on Google Cloud, by triggering a cloud function on each new object that is being written, you could also, along with the data, you could also send the description of that data, right? So where is it coming from? Who is the owner? And how is this useful? Like, what kind of use cases? And any other attribute which you think is relevant for your business, right? So you could capture all of those. So each object will have this metadata. And using a database of your choice, you could write this metadata as part of that ingestion itself to either Cloud SQL, which is a managed SQL database, and BigQuery, which is an enterprise data warehouse, serverless data warehouse offering. And then the access and user interface part of it, right? So if you'd like to make this data available for the end users, or expose some of this, maybe some processed data, for the end users via an API interface, there are options to do that as well. One is the API gateway, API management platform available on Google Cloud called Apigee. It's just not the gateway. It also has the functionality for API rate limiting, throttling, and analytics at API level, etc. And then there is cloud endpoints too. You will be able to turn any backend into a API interface using cloud endpoints. And recently, there has been an announcement for the Google's GCP's API gateway as well, which is currently in beta. So those are the options. Now, we have ingested data and it's properly cataloged and it's searchable. When I say searchable, it's about the metadata itself, not the actual contents of the data, right? So you'd like to discover. So from that perspective, so and how do we protect it and secure it, right? So security is of great importance for any organizations, and particularly so for enterprises where there are compliances and all that stuff, right? So there is identity and access management service called Cloud IAM, where you can create users, and cloud identity is where you can actually create groups of users. It has if you would like to federate the identity from your on-premise identity platforms like Active Directory, etc. That's also possible. And you could come up with the granular roles which are necessary to be assigned to specific sets of or groups of users. We could also make some of this data available via using signed URLs and access tokens, etc. And when it comes to the key management, there is a service called KMS. Either you could let the platform take care of the entire encryption key management for you, which is transparent, or there are options for us to supply encryption keys and manage the encryption keys as well. And then there is cloud operations, which is earlier it was called Stackdriver, which has it is a collection of services like logging and tracing, debugging, and alerting and monitoring. So that can be used to for audit and monitoring purposes, right? And then there is Identity Aware Proxy, which is part of GCP's Beyond Corp security strategy. So that's about security. And then on the processing and analytics side, depending on what kind of use case you are interested in, right? There are multiple options. We already talked about data flow, ability to kind of write the sliding window analytics, etc. on the incoming data. You could also deal with the batch data too. And then there is BigQuery, the serverless data warehouse. The good thing about that is you don't have to really worry about how many nodes and what distribution key, what sort key, vacuuming, etc. So you just bring in your data and then analyze it, right? And then the collection of services, API services, Vision API, speech, and there is also AI platform, with hosted notebooks and all that stuff that can be used for your data science needs. And if you are ingesting data which is time series in nature and analytical, then Bigtable is the right database, right? And then there are other services which are not mentioned here, like Spanner. So basically, the idea is once the data is available on Google Cloud Storage, you will be able to pick the tool of your choice, right? That's one of the promises of the data lake, that you will be able to identify first discover the data and then identify what tool would be the right fit to solve your specific problem, and then go about it. Now, the AWS side of this story is not all that different. The fundamentals, still remain the same when it comes to ingestion, when it comes to cataloging and search, and security, access and API interfaces, and the processing layer, right? But then there are multiple ways for you to build an enterprise data lake on AWS. This was one of the earlier ways. Again here too. S3 is at the center of all of this. That is the data lake. And similar to the GCP side, we will be tapping into the metadata functionality, object lifecycle policies, and rich IAM and access controls, etc. But then this solution is available as a cloud formation template, and you could try it as well. So basically, it is a management and a control interface for the data lake, right? So as you can see, there is a data lake console, kind of like a static page, and also the data lake CLI. I mean, if you'd like to interact with your data lake via the CLI, both of these are available. It's part of the CloudFormation template. And for access, the Cognito service is used for providing sign-in and authentication for your small application, that is your data lake, right? So the interface to your data lake. So we are granting access to it, via Cognito. And if you are an enterprise and you have identity already in a Active Directory, you can actually sync that with Cognito. Basically, that would allow you to use the groups that you currently already have in Active Directory, and then provide them the relevant access on the data lake as well. Now, the gateway for all of this basically is the Amazon's API gateway, and behind that, cloud function, which Lambda. We just talked about Google, so still in cloud function. So basically, here it's Lambda, and which will be invoked to enable the further interactions that you see, right? So you could put data in S3, and then AWS Glue here is the managed ETL tool. All of the complexity of running an ETL cluster with Spark abstracted away from you, so that you can just write Spark code for your transformations. But in this case, it's basically using serving as a data catalog. You point to data sources, and then Glue's crawlers can start cataloging that data, and then once its catalogs are available, you'll be able to point to them and create external tables in Athena. Athena is basically managed Presto. And serverless querying tool. You will be able to write these queries and analyze your data, perform ad hoc or interactive analysis. And if your workload benefits from high throughput NoSQL database, for both read and writes, then DynamoDB is the right database. You could also, the metadata also could be stored in DynamoDB itself, right? So that is another use case. And Elasticsearch, if your workload is text search heavy, and CloudWatch for monitoring, alerting, IAM roles we already talked about, and CloudWatch logs for auditing purposes, right? I know this is another solution which is like relatively new. We have tried this as well for many customers, and unlike in the previous approach where you still had to, even though it's a neat solution that you can just deploy, but still there is some kind of management overhead in terms of deploying it and then maintaining access policies in multiple places, so on and so forth. And lake formation is supposed to solve exactly these problems, right? So it's kind of like the data lake service where the crawlers and the data cataloging, security settings related to a data lake, and the ETL transformations and prepping data and access controls are in one place, centrally managed. And obviously the backend for all of this, where the actual data sits, is S3. So that's about lake formation. And the tools that we have already seen, Redshift is like BigQuery, an enterprise data warehouse, petabyte scale. It has great enterprise features like workload management, etc. And EMR is the managed Hadoop cluster on AWS, and Athena we already talked about, right? So that's about lake formation. So now that we've talked about how to build data lakes on AWS and also GCP, I thought I'd take you through some case studies, that might be relevant here. This is about a renewable energy company. They ingest data from multiple sites. Each site is a collection of multiple wind and solar farms, right? So these devices keep sending data, and they're in the business of coming up with insights on top of this data and remote device management, KPIs, and etc. Right? So their problem was they were on-prem. They were using MongoDB for their the time series data, ingesting all of this data here, and self-managed Hadoop clusters, and there were issues of reliability and one of the things that we initially mentioned, right? So although they were, when we started working with them, they were currently on building KPIs, etc. They also wanted to enable advanced analytics on their platforms, right? Like forecasting when a device might fail, depending on the historic data, and performing sliding window analytics, and rolling averages, etc. Right, and so on and so forth. So we ended up migrating them to Google Cloud Platform. Sensors sending data, edge servers, because first the data goes to the edge server, which is on the site, and then it comes to Cloud IoT Core, which is the managed IoT platform on Google Cloud. It serves as a device registry and device management service, and it has tighter integration with PubSub and Cloud Functions, etc., so that some of the devices can be managed as well from Cloud IoT Core, right? So you could trigger a Cloud function and then do something on the sensor side too. And PubSub, we already talked about, it's managed Kafka. So data from Cloud IoT Core goes to PubSub. And then you'll see Dataflow branching out into two pipes here. One is writing after performing the sliding window, rolling averages, etc., and writing them to BigQuery. And then the raw data is going as is to cloud storage, if you can see. And that is the data lake, right? So earlier they did not have it. They were just ingesting this data to MongoDB, and then later on use Spark connectors, etc., and then perform analytics. So cloud storage allowed them to ingest all of this data in its raw format, and perform ad hoc analytics, right, using Cloud Data Proc, which is the managed Hadoop cluster on Google Cloud. So yeah. And then on the other side, the data that is written to Bigtable, a Maven application actually ingests this data, and then writes to MySQL. And the web app is deployed on GKE for consumption. And then there is this other use case for a largest B2B e-commerce company in Indonesia. Their problem statement was that traditional systems, data being ingested from Oracle and the likes of SAP, the previous ETL jobs were taking, they were not reliable, and also from the time data gets generated to it being available for analytics, there was a significant delay because these jobs used to run in batch manner. The solution to that was we kind of introduced a CDC platform called Debusium. There is a great community around it. They're adding more and more connectors and syncs as we speak. So basically subscribe to the production databases, production servers, and then record all the changes, stream all the changes that happen in terms of creating, inserting and deleting and updating records, etc. So all of this data goes to cloud storage. Again, kind of the data lake, right? So as you can see, the third-party data sources, SAP and SQL, we're ingesting data using Cloud Dataflow and Airflow. That is for SAP side. And then for relational databases where we need to immediately sync changes as they're happening via Debusium and Kafka connector. All of this data goes to data lake, and from BigQuery we'll create external tables to the data that is in the data lake, dedupe records, because there are multiple statements which are being inserts, deletes, and updates. We have to do reconciliation so that you could load the final data, right? So, and then a purpose-built data mart in BigQuery itself. All of this being rendered via visualization tool Power BI. So that's pretty much it. I hope you found this session useful. Please feel free to interact with the other attendees on Slack. You can see the Slack channel here. If you have any questions, please feel free to reach out to us. And also, from time to time, we record everything that we do interesting on our engineering blog. So feel free to visit it and see if you find something useful. Thank you.